Alright, this video is a review, or actually to go over KSP, which is the next chapter, which is chapter 16. When you look at a KSP table, it has to do with solubility product constants, which are basically compounds that we consider to be insoluble. So what you're doing is we're actually calculating the slight solubility of something that we normally in chemistry call it insoluble. So the first thing you do is, if you pay attention to KSP values, the larger a substance's KSP value, the more soluble it is. If it's the same number of ions, you're allowed to compare them. So if you look right here, BaCO3 and CaCO3, so barium carbonate and calcium carbonate are both two ions. Therefore, you can figure out which one has a greater solubility based on comparing the two values. So if you look, notice 4.9 to the negative ninth versus 2.6, we would say calcium carbonate is more soluble than barium carbonate because the number is larger. And if it's different numbers of ions, you have to solve for molar solubility, or S, which we will do later, either Tuesday or Wednesday, we'll go over. So this is a solubility table. So it comes in handy. You can look it up if you need the values, or you can interpret overall solubility and compare values, which we'll do later. One of the first things you have to be able to do is write an equilibrium expression, very similar to what we've done with acids and bases and gases. What we do is we always write the insoluble compound. Due to solubility rules, it'll be considered insoluble on the left, and we write the subscript little s right there, as you see. So for example, calcium fluoride is insoluble, so we write CaF2 as a solid. When it breaks up, we use the subscripts to represent the coefficients of the ions. So in this compound we have one calcium, so we write Ca2+, but we have two fluorine ions, so we write 2F-, and we label them aqueous. That is how we write the reaction. So that's how you write the reaction. You're going to take the compound that is insoluble, write it as a solid, it's written on the left. You're going to break it into its ions based on the subscripts. When you go to write an expression, remember solids are never included in an equilibrium expression, nor are liquids. So this part of the reaction is never included. So it's really just products of the ions on top. We don't include the CaF2, so the KSP expression is only going to have a top. It'll never have a bottom. So the KSP expression is Ca to the first, y, coefficient's 1 there. The coefficient in front of F- is 2, so F- raised to the second power, or exponential power of 2. So then my KSP expression is going to be Ca2 plus F- to the second power, and that is how you write a KSP expression. Here's another example, barium carbonate. If I was going to write out barium carbonate, I'd write BaCO3 as a solid. I'm going to break it up into its two ions. I'll have Ba2 plus CO3 2 minus. If I go to write an equilibrium expression, I'm not going to include the solid, so KSP is just going to be equal to the concentration of Ba to the first and CO3 2 minus to the first. And that would be my KSP expression. What if I took something like lead 2 iodate, right? If you look at lead 2 iodate, it's down here, PbIO3 to the second parentheses 2. When I go to write out the expression, I'm going to write Pb2 plus, so Pb2 plus because there's one of them. The subscript for iodate is 2, 2IO3 minus, and my overall KSP expression is going to be Pb2 plus to the first, IO3 minus to the second power. Now, first thing in the chapter we have to do besides equilibrium expressions is we're going to have to find KSP. So we're finding KSP. There's 4 calculations in this chapter. Finding KSP. There's several steps that you have to do to figure it out. It's not that hard. Step number 1, you're going to write out the reaction. So first thing you're always going to do is write out the reaction. So if you notice right there, I've got my reaction right there written already, so I'm good to go. Second step, I'm going to fill out an ice table. I call it a mice table, like a mini ice table, because when you go to fill this out, you only care about the right side. The left side is useless since it is a solid. We don't include it in the equilibrium expression. So here's my reaction. I'm going to just make my ice table like this. Boom, like that. I have no initial values, so this is going to be 0 and 0. Then I'm going to do my change line. I'm going to use S instead of X for this chapter. So the coefficient for, or the coefficient for calcium is going to be 1. So I'm going to say plus S. The coefficient for F minus is 2, so plus 2S. Then I'm going to drop it down to the E line. I get S and 2S. Those are my E line values. So I fill out my little mini ice table. That's the next thing I do. Third thing is I write out my expression. So on the side over here, my KSP expression is going to be KSP is equal to the concentration of Ca2 plus and the concentration of F minus squared. I have my expression. Step 4, I'm going to find molarity, S, using the stuff that they give me. They have to give me grams, a volume that I can turn into liters to find molarity. If you don't remember, molarity is equal to moles over liters. So they'll give us some way to find molarity in this chapter. Molarity is the same thing as S, or solubility. Same thing. And we're going to plug those values into the E line. What you have to be careful of is once you find S, you have to pay attention to the coefficients when you're plugging into the E line. See how this is just simply S, this is 2S, the value will be doubled. So what do they give me in this problem? They give me 1.5 times 10 to the negative 4th grams. So I'm going to go 1.5 times 10 to the negative 4th. I'm going to divide by the molar mass of CaF2, which comes out to be 78.1 grams, which is going to give me, according to my calculations, 1.9 times 10 to the negative 6th moles of CaF2. I need to know my volume. I care about mass and volume in order to do this. If you look right there, they've given me my volume, 10 milliliters. To get molarity, I'm going to change it to 0.010 liters. So when I get my molarity, or go to get my molarity, I'm going to divide that by that, and I'm going to end up with a molarity of 1.9 times 10 to the negative 4th. That is going to be my S. So what do? I have to go to my E line value. I'm going to go to my E line value and plug it in. Use the coefficients when you plug it in. So I'm going to come over here. For Ca, it's going to be just 1.9 times 10 to the negative 4th. But for F minus, I have to double it because the coefficient's 2. I get double the amount of ions. So when I double it, I'm going to get 3.8 times 10 to the negative 4th. Plug it in for my E line. I got my E line values. The last step in the problem is you drop whatever the E line values are after you solve for them directly into the expression and find KSP. So what I'm going to do is I'm going to take my values. My first one is going to be this one. I'm going to put 1.9 times 10 to the negative 4th right there for my Ca. My F minus is going to be 3.8 times 10 to the negative 4th. Bracket, I got to square that sucker. To solve for KSP, I square 3.8 times 10 to the negative 4th, squared times 1.9 times 10 to the negative 4th, and I solve for KSP. My KSP comes out to be, I believe, like 2 point something times 10 to the negative 11th or whatever. At that point, you just plug in at that point, your setup's good. You're just plugging in and doing your calculations. So when you go to solve a KSP, there's 4 calculations in this chapter. When you go to solve a KSP problem, keep in mind you want to do it in order because sometimes the number of ions, they will ask you the ion concentrations before you solve for KSP. It's a common thing in AP. So you have to be aware of the ion concentrations. They will be different. Why? When you go back to the mice table, look right here, S and 2S. Notice it changes the values down here, so pay attention to it. Do your E line work, do your molarity calculations, plug them in, get those good and set, then just drop them directly in the expression, and then you solve for your KSP. Okay? A lot of times on the AP exam, they will focus on the concentration of the ions before they have you solve for KSP. That's how you find KSP. 5 quick, easy steps. Reaction's easy to write. Fill out the ice table. It's a mini ice table, actually, so it's a little easier to fill out and do your calculations. All right, so let me hit pause.